This is section 8.1 on systems of linear equations. A system of equations is a set of two or more equations involving two or more variables. Usually our variables are going to be x and y, but if you have three variables, you could have an x, a y, and a z. If the two equations produce lines, the system is said to be linear, and so that's really what we're going to focus on in this class. So first, we're going to verify that the point 2, 5 is a solution to the following system. Okay, so to do that, we're going to substitute 2 for x and 5 for y in each equation. Okay, so that's 5, and then because I'm not exactly sure if this is going to work out, I'm going to put a question mark above the equal sign. 3 times 2 minus 1. And 6 minus 1 is 5, and so the point satisfies or is a solution to the first equation. But we've got to work through both of them to make sure it's a solution to the system. Okay, so 5, is that equal to negative x, or negative 2, plus 7? And negative 2 plus 7 is 5, and so it also satisfies the second equation. So we will say yes, the point 25 is a solution to the system. So if I'm given a system of equations, sometimes I want to figure out the solution or solve the system. And to solve a system means to find the values of the variables that satisfy each equation. So we're given this system, y plus 4 is equal to 2x, and y equals negative 1/2 x plus 1. And we want to solve this system by graphing. So the first thing that I'll do, because I know I can graph a line pretty quickly if it's in slope-intercept form, or y equals b plus mx, or mx plus b, I'll move the 4 to the other side, and I get y equals 2x minus 4. And so for this first line, which has a slope of 2, the y-intercept is negative 4, and we'll go ahead and graph our first point at 0, negative 4. From there, we're going to use the slope to find another point on the line. And a slope of 2 can be written as 2 over 1, so the rise is 2 and the run is 1. And now that we have 2 points, we can connect them with a straight line. So I'll graph the next line the same way, y equals negative 1/2 x plus 1. So this time the y-intercept is at 1, and the slope is negative 1/2. So I can count down 1 and right 2 and find another point on that line. So for an ordered pair, to satisfy a linear equation, it has to lie on the line. So in order to satisfy the system, it has to lie on both lines. And where that happens is where the lines intersect. So we look for the intersection and we name that ordered pair. So it looks like the solution is at 2, 0. Well, we have different kinds of systems of equations. And the first kind, which is what we just saw, would be a system that is consistent and independent. So if you see the lines intersect one time for a linear system, there is one solution. If it turns out that the lines are exactly the same, every point on one line is on the other as well, and that means there's an infinite number of solutions. If the lines never intersect, meaning they are parallel, there's no solution to the system. So we're given this system of equations and we want to classify the system. It would help if both equations are written in the same form. So I will just transform this first equation to slope-intercept form. Okay, and to do that, I'd first subtract 5x from both sides. And that's negative 2y equals 10 minus 5x. And then divide both sides by negative 2. So y equals 10 over negative 2 is negative 5. And then negative 5 over negative 2 is positive 5 halves. And then an x. So negative 5 plus 5 halves x. Okay, or 5 halves x minus 5. Okay, so we compare the slopes of the two lines. And we see they're exactly the same. Okay, so that means these lines are slanted the same. But are these two lines exactly the same? Well, if they had the same y-intercept, they would be the same line, but they have different y-intercepts. So that means the lines are parallel to one another. Okay, and now I know there is no solution to the system, and the system is inconsistent. And let's take a look at an application. So Connie is deciding between two sales positions. She can work at Marsha's and receive $12 per hour, or she can work at Flora's and earn $8 per hour plus a $60 commission each week. So how many hours would Connie have to work to earn the same amount at each position? Okay, so we'll write two formulas. So one will say M for Marsha's is equal to 12H, where H is the number of hours worked. And the next one is F is equal to $8 per hour, so 8H plus a $60 commission, so we'll say plus 60. Okay, we can do this a couple of different ways. One is to set these expressions equal to one another. So 12H equals 8H plus 60, and solve the equation for H. Okay, so we would move the H's together, so subtract 8H from both sides. We get 4H is equal to 60, and then divide both sides by 4. Okay, so H is 15 hours. If instead you would like to graph these lines on my calculator and y equals, I'm going to type 12x for the first line and 8x plus 60 for the second. Since I'm kind of unsure what the window should be, I'm going to try Zoom 6, which is the standard viewing window, and then Zoom 0, which is Zoom Fit. And then I'm going to zoom out around this upper right-hand corner, so Zoom 3, because our goal is to see where these lines intersect. Okay, now that I see the intersection, I'll just use the intersect feature. So second trace, which is calculate, and then number 5, and hit enter 3 times. Okay, so there it is. X equals 15 is when those salaries, the weekly salaries, would be the same. And lastly, if Connie expects to work less than 15 hours per week, which job should she choose? So I'm going to go back to my calculator. So if I select the trace button and just kind of run my cursor along the graph, it will tell me which graph I'm on in this upper left-hand corner. And so Y1, or Marsha's, is my blue line. Less than 15 hours is to the left, so kind of where my cursor is. I want to see which one of these jobs would pay the most, because you want to make the most money. And so I jump up to the other graph, And I can see that it's this line, y equals 8x plus 60. And that tells me that she would make more at Flora's if she does plan on working less than 15 hours per week.